All right, so this is going to be a video where I go over the concept of remainder theorem by solving some example problems. So hopefully by the end of me doing these example problems, you'll understand the concept of remainder theorem a little bit better. So number one, it says explain what the remainder theorem is and how it relates to polynomial factoring. All right, I'm going to answer that over here. So I'm basically just saying what remainder theorem is and how it relates to polynomial factoring. So what remainder theorem is, say you had a polynomial p. So I'm just going to say p of x is equal to some polynomial. All right, and the way remainder theorem works, it's if, let's just say we said x minus a. If x minus a is a factor of p, so of that polynomial p, then p of a is equal to 0. Okay, so that's part of remainder theorem, is if you actually have this factor x minus a right here, and it's a factor of p, then if you actually plugged it into the function, you would get a 0 out of it. Okay, so that's basically telling you that there would be no remainder on that because x minus a is an actual factor. Okay, now the corollary to that, if I said something like if x minus a is not a factor of p, then p of a is not equal to 0. In fact, p of a is going to be equal to the remainder of p divided by x minus a. Okay, so remainder theorem basically has two different parts for it. You can kind of think of it as like factor theorem and remainder theorem. But the first one is, as I said before, if x minus a is a factor of p, then p of a, if you plug in a directly into p, then it's equal to 0. Now, if the opposite is true, so if it's not a factor of p, then p of a is not equal to 0. In fact, p of a is equal to the remainder of that polynomial p divided by that x minus a. Okay, so that's basically the answer for number one. So this one says, consider the polynomial f of x is equal to x cubed plus x squared minus 10x minus 10. Is x plus 1 a factor of p? So based on how we answered number one, we can actually answer number two using remainder theorem. So if x plus 1 is actually a factor of p, and this should say p, not f of x. This is not written very well. I got to change that. I'll change that on the actual document. But if that is true, then you technically should be able to take p of negative 1. So I kind of always think of it, this is x plus 1. So if you set this equal to 0 and solved, you would have x is equal to negative 1. So that's essentially where this negative 1 comes into play. Sometimes I just kind of, abstract that all away and just think it's the opposite of whatever's after the x. Okay, but sometimes it's not 1x, like this one, it's 1x plus 1. Sometimes it's like a 2x plus 1 or something like that. But we'll go over example problems like that. So it says find p of negative 1, and this will basically tell you whether x plus 1 is a factor or not. So what I'm going to do is plug negative 1 into this p function right here. So you're going to end up with negative 1 cubed, which is just negative 1, plus negative 1 squared, which is just positive 1, minus 10 times negative 1 minus 10. Okay, this math's not too complicated, so I'm not going to use a calculator for it. I'm just going to write it all out. So negative 1 to the third is negative 1. Negative 1 squared is 1. This minus minus becomes just a positive 10, and then we have a minus 10 right here. Okay, now if you add these up, negative 1 and 1 cancel, and then 10 minus 10 cancels, and you end up with 0. So the answer for this one, is x plus 1 one of the factors of p? You would say yes. And the explanation would be kind of how I showed work here. And the main thing is the fact that p of negative 1 is equal to 0. Okay, so that can be my explanation for that. The next one, it says the graph shown has x-intercepts at the square root of 10, -1, and negative square root of 10. Could this be the graph of this p of x function right here, which is the same as the one above? Explain how you know. Okay, so it says that there's x-intercepts at the square root of 10. Okay, so that would be like right here. This is square root of 10. Okay, this one right here would be the -1. And then this one right here would be the negative square root of 10. So those are the x-intercepts. I just basically threw them on the graph. And we're just trying to see, is this blue graph, could this actually be this p of x equation right here? Okay. Well, first thing we would need to do for this is to actually see, is -1 and then plus or minus the square root of 10, are those actual solutions to that p equation? So what I'm going to do is I'm going to figure out what p of each of those is. So I'm going to do what's p of the square root of 10. I'm going to do what's p of -1. Now we already know p of -1 is 0 because we calculated it right there, okay? Like I said before, this expression right here is the same as the one above. So we already know what p of -1 is. Two birds, one stone right there. P of negative square root of 10, we're going to figure that out as well. So we're figuring out the p of plus or minus square root of 10. So to do that, I am just going to plug it in directly and hope that the math comes out a little pretty here. We have the square root of 10 and we're cubing it, minus the square root of 10 squared, minus 10 root 10 minus 10. Okay. Well, this one actually simplifies pretty easy. The root 10 times root 10 times root 10 is just going to be 10 root 10. Okay. This one is going to cancel and just be 10. So essentially what's going to happen here is this 10 root 10 and this 10 root 10 cancel, and then 10 minus 10. This is supposed to be a plus. Okay. And then this 10 right here minus 10 right here is going to make this be equal to 0. Okay. So p of the square root of 10 does check out. Let's do p of negative square root of 10. So you're going to end up with the square root of negative square root of 10 cubed plus negative square root of 10 squared minus 10 times negative root 10 minus 10. All right, let's do some simplifying here. This right here is going to end up being positive because of the squared, which cancels out the square root. And the 10 minus 10 will cancel here. Okay. Now this negative root 10 times negative root 10 times negative root 10, that's just going to be negative 10 root 10. Okay, and this one is going to be plus, so you have positive 10 root 10 and negative 10 root 10. These two things are going to cancel as well, and you're going to end up with 0 for the answer for that one. So it does look like the x-intercepts all match up with what the graph is showing. The next thing we'd have to test is the y-intercept right here. Okay, the y-intercept should be negative. This isn't really drawn to any kind of scale. I don't know what's going on with the y, so I'm not really going to worry about so much of the value here besides that it has to be negative. So let's look at this right here. So if you plugged in 0 for x, you would get, so p of 0 is equal to 0 cubed plus 0 squared minus 10 times 0 minus 10. Okay, well 0 and 0 and this is 0, so you're left with negative 10. Which does work out with what the graph looks like. This could be a negative 10 right here. So the answer for that, could this be the graph? I would say yes. And it says explain how you know. And I know based on the characteristics. So I checked the x-intercepts and y-intercepts. Explain how you know. I know because the x and y-intercepts check out. X-intercepts and y-intercept check out. Okay. Not a very mathematical answer, but you understand what I'm getting at here. Okay, number 4, it says, use remainder theorem to find the remainder of the following divisions. okay? So all I would need to do for this is, so for this bottom part right here, it's x plus 2. So if I set this equal to 0 and solved for x, you would get x equals -2. So what I need to do is put -2 into this top part, this numerator of this division right here. So we're going to end up with -2 squared plus 3 times -2 plus 1. Now, if this is equal to 0, then x plus 2 is a factor. Okay, and if it is a factor, the remainder would be 0. So I'm basically just going to try to figure out what this is, and whatever this value is going to tell me what the remainder is. So you're going to end up with 4 plus -6 plus 1, which is -2 plus 1, and you end up with -1 for your answer for this. And then I'm going to do the same thing with the next one. This time it's x minus 3 on the bottom, so I'm going to do x minus 3 is equal to 0. This means our x that we're going to be testing out is 3. Okay, so I'm going to plug in 3 to that top part there. So it's going to be 3 to the third minus 6 times 3 squared minus 7 times 3 plus 9. Okay, well, this is going to be equal to 27 minus 54 minus 21 plus 9. Okay, let's see here. This is going to be -12. All right, and then this is going to cancel out here to be 15. 15 minus 54 is going to be -39, and that will be your final answer for that one. All right, so that's basically 5 example problems involving remainder theorem. If you have any questions about anything in this video, let me know.